Hello and welcome back to my channel. In this week's video I will make this axle, this part. I use it for a coffee grinder, a special one that I am designing myself right now for a school project. But I don't think that project as a whole is really interesting to you guys. So I will probably not show that, but the making of some of the parts can be or is quite interesting, especially on this part. The milled parts, the CNC milled parts, because I will have to mill a external and an internal hexagonal shape into this axle. On one side it's the outside hex part, and on the other side of the axle it will be the internal hex. But before that I had to turn the axle itself, and for that I use this grooving tool to make the grooves for the retaining rings. This actually worked out pretty well. For that this just some tool I had laying around. I don't even think it's a really high-speed steel. I mean it probably was, but doesn't look like it because it's so rusted. And then right here I had about I basically was touching the the tool holder with the jaws, so I just broke off the part because it would have been annoying to take the cut-off tool further out, so I didn't do that, and it still worked out. Then I faced the other side, then measured, and I was about half a millimeter oversized or too long. So I had to turn it down by about half a millimeter, which worked out pretty good. And then you always have to put a chamfer on it, obviously. And that's basically all the turning done for this project. The outside diameter of it was already 10 millimeters, and the bearings fit pretty well. If you're asking yourself what this reduced diameter on the top is, that's so the mill doesn't have to mill away so much material. It's the biggest diameter that the hex can have. That's why I reduced it. Right here I'm installing my calibration cylinder. On that piece of steel I can then mount the indicator to the spindle, and with that I can go around the part and then adjust X and Y until I'm at 0 in both axes. As you can see right there, when the needle doesn't move anymore, that means that the part is in center. Then I just zero it in the software, and then I have the perfect center of this part. For set, I still use a piece of paper. On these parts it doesn't really matter that much, but I for sure will have to at some point make something that will work better. And as you can see, after that I just mill the hex on it. I was going really slow, and also I definitely could have put more load on this end mill. I could have gone probably twice as deep and quite a bit faster also, and obviously a lot more sideways, but that's things that I learned, and then I can change them for the next time in the software. And that was just basically now the roughing with that end mill. Now we're coming with a 3mm high-speed steel 4-flute end mill. In this operation I'm cutting away the corner radius of the end mill and cleaning up the bottom. And in this step right here, I'm cleaning up the outside with the end mill. The idea was that I would get a nice surface finish from this end mill, but you can see that there's a visible step. You can't actually feel it, but you can definitely see it. And you don't think that you can't feel it, but you can't. And then for the second side, to get the 0 in the set, I just moved the machine to 0 and then put the part up against it. And then I changed the tool to the center drill, and well, the feed was way too high, even though I turned it down to like 30%. But that's also a lesson I have learned now is for center drilling I really need to slow down the feed. And for normal drilling, this was also slowed down, but this actually worked pretty well after it had completely entered the material, because before it was pretty loud when it entered the material, but when it was fully in the material, it sounded just fine. And then this is a 1.6 millimeter 2-flute tungsten carbide end mill that I got from work. They didn't use them anymore, or better said, they already are done. Their lifetime is over, these end mills. So I asked if I could have some of these, and then yeah, that's how I got them. And they actually are still fine for this, and they are more likely made, I think, for aluminum parts and not steel, but they still worked. You just can't push them as hard as you would steel end mill, but this tiny end mill you don't push anyways, or at least I don't. There I also milled in multiple steps with roughing and then cleaning up the surface and the bottom. And then on top I milled a chamfer on, because I don't have a chamfer mill. And as you can see, that's how fast the program would be programmed to, but I had to slow it down so it for the rest of the program, because I didn't want to break it. And as you can see, it looks pretty good, except for the bottom of the hole, because the drill I used is one that I ground by hand, so it isn't very accurate or nice, but it looks good. And this was the part that I made. For tolerances wise, they were about 2 or 3 hundredths of a millimeter too big or too small, depending on the internal was too small, and the outside was too big, because the machine just gets pushed away. But I can live with that. If I can compensate for it, I don't really have a problem. Now for the end of this video, this right here would be the grinder that I talked about in the start of the video. And the idea is that the gears are there to speed up the flywheel, or this plate at the moment. There are no weights on it, but this should be the flywheel. It will spin the flywheel in the opposite direction that you spin, and at twice the RPM. That's the idea. So you can store more energy and make grinding the coffee easier. And with that, thank you for watching. I hope you liked this video, and until next week.